Hi, my name is Bernadette Grantham, and this is my Lab 1 charge tapes. So, the purpose of this lab was to see how charged pieces of tape interacted with each other, and to determine how to find the charge and how much excess charge there is. We use Newton's first law and Coulomb's law to determine this information. Newton's first law was to find the gravitational force on the tape, and Coulomb's law was used to find the electrical forces between the charged pieces of tape. Both of these equations are to the right. Some of the assumptions we made were that both pieces of tape had the same charge and that they are charged positively, which I did test by seeing if they were attracted to each other. I ran a pin through my hair, which would charge the pin negatively, and then see if the tape was attracted to it as it should have been. I also ignored air resistance, and I modeled each piece of tape as a point charge so that I could use that in context of Coulomb's law. So for the experiment, I started with 2 neutral U-tapes, and then I charged the tapes by pulling them off of a base tape, which is a piece of tape stuck to a table. I tested the tapes, as I said earlier, to make sure that they are both charged positively. Then I created the bridge by taking one of the pieces of tape and taping it over a gap, and then I brought the other piece of tape close under the other one, which caused the piece of tape on top to start floating as it was repelled by the other piece of tape. This is shown in the figure to the right. Then I measured the distance between the 2 pieces of tape when the floating began, and I learned that that was 0.0289 meters. I also measured the length and the mass of the tape, which the length was 0.213 meters and the mass was 0.000213 kilograms. I also figured out the gravitational and electrical force using Coulomb's and Newton's laws, and those are both on the screen. And then I measured the electrical charge, or I calculated it actually, and I learned that that was 1.39 times 10 to the negative 8 coulombs. Some other observations, as I said earlier, were that they were both positive, the pieces of tape, so they repel each other, and that was what caused it to float. So my code for part 1 is to the left, the more important parts. I use the things I determined in the experiment, like the width and length and mass, to figure out what the charge is. I found that was the same as what I had it, which was 1.39252 times 10 to the negative 8 coulombs. Both of the pieces of tape in the result to the right are modeled by dots as they are point charges. The purple arrow pointing up is the electrical force, and the yellow arrow pointing down is the gravitational force. For the second part of the code, more of the important stuff is to the left, and like the electrical field and the line charge, and how to find that. The charge, this code gave me the magnitude of the electrical force and the magnitude of the gravitational force, as seen in my result. As you can see, the charge from the code that I got from that was 2.69 times 10 to the negative 8 coulombs, which was not the same as from my experiment in part 1. So modeling the tapes as point charges both in the experiment and the coding leads to less accurate results than modeling it as a line of charges, because you're basically taking out all the varying parts of the electrical field throughout the length and just saying it's one dot. Possible sources of error were objects touching the tape, allowing the tape to lose some of its charge, measuring the weight of the tape and measuring the length and stuff also is not exact, and unaccounted forces on the tape from other surroundings like air resistance and such. So what if the signs of the charges were reversed, meaning the electrons are positive and protons negative? The names would just switch. The results of the experiment would be the same, because the like charges would still repel and the opposites would still attract. The point charge of the model for the Y question is simplified and does not take into account how the electrical field varies over the length of the tape. The line charge model is much more realistic and accurate as it spreads the charge along the length of the tape. And that is all. Thank you.